Hi guys, welcome back to the channel. My name is Jag, and in today's class, we're going to continue with our Science 10 content, and we're going to go through the mirror equations, part 2. Okay, and this is for the concave and convex mirrors. So let's get started. All right, so here we are. So I put mirror equations, part 2. And what we're going to do here today, okay, is we're going to use the mirror equation. Okay, but remember, we also have to find not just the distance of the image, we're also going to find the height of the image as well. Okay, so let's try this question. I'm going to read the question out loud and just write down what's given in the question. So I have a 2 centimeter high candle. So this is the height of the object, okay? It is 2 centimeters. It's placed 15 centimeters in front of a concave mirror. So the distance of the object is 15 centimeters. All right, and it's in front of a concave mirror. The focal length is given. The focal length is going to be 30 centimeters. Okay, and the question will always be the same, okay? So it says, how far behind the mirror does the candle appear and how large is it, okay? So first we're going to start off with the distance of the image, okay? So di. So one more time, remember you're just going to write out the formula here. So it's 1 over f equals 1 plus di, 1 over di, and then plus 1 over do, okay? So again, when I'm looking for the image distance, you're just going to rearrange the formula. So 1 over di equals 1 over f minus 1 over do, just like this, okay? And now you can just plug in your values. I have the focal length, which is 30 centimeters, and the distance of the object is 15. Okay, I'm going to do a common denominator here. Okay, and again, the reason I'm doing the common denominator, okay, is so I can get like an exact value, okay? So this is going to be 1 minus 2 over 30. So negative 1 over 30, okay? Which is the fraction here. Remember again, this is 1 over di. So what we're going to do is just flip over the two fractions. Okay, so di is going to equal negative 30 over 1. Okay, or it's equal to negative 30 centimeters. Okay, and that's our answer for the di value. Does everyone see how to do that? I can see the mirror equation is very simple, okay? Make sure you're doing the common denominator, especially if your answer is decimal, okay? I want to do the common denominator to get just the exact answer here, okay? All right, so the second part, what we're going to look for, let's just write it on the same side here. Okay, because it is saying how high or how large is the candle here and the candle image. Okay, so the height of the image. So this is the formula. Okay, so negative di over do equals hi over ho. Okay, what we're going to do now is just plug in the values. Okay, so we see that our di value here is negative 30. So this negative is actually part of the actual equation, okay? So negative 30. And the do distance is given as 15. I'm looking for the height of the image, so I'll put hi. And then the height of the object is given in the question, it's 2 centimeters. Okay, so it looks something like this, okay? Again, make sure you are writing concluding sentences, okay, at the very end when you get your answer. Okay, so in this case, actually, it would be therefore the distance of the image from the mirror is 30 centimeters. Okay, and it's negative because it's on the opposite side of the mirror. Okay, so in this question, we're just going to cross multiply, okay, to get our answer. The two negatives cancel out here, okay? So what we're doing is 30 times 2, and then divided by 15, okay? So remember again, I don't have to get like an exact answer, okay? In some cases, it might be an exact answer. So we'll put hi equals 4 centimeters. Okay, and this is basically the height of the image. So again, I'm just boxing, okay, my final answers here. Okay, so the distance of the image is 30 centimeters from the mirror on the opposite side. And the height of this image formed is going to be 4 centimeters, okay? Now, there are some teachers who will have you draw the ray diagram, okay? And your ray diagram has to be very specific here so you can actually get these final answers. Okay, are there any questions here? All right, that looks good. So with that, okay, let's try another example here, okay, from this worksheet. Let's write it at the back. Okay, so again, I'm going to just read out the question. A trucker sees the image of a car passing her truck in her diverging rearview mirror, and the focal length is given here. The focal length is negative 60 centimeters, okay, like that. And the car is 1.5 meters high. So let's put the height of the car. Okay, it is 6 meters away. So this is the distance of the object, which is the car. It's 6 meters away. We're looking for what is the size and the location. So that's the distance. What is the size and the location of the image? Okay, so first what we're going to do, okay, is you do notice here, okay, I have the focal length. I'm going to, let's put change, okay, the focal length. Into centimeters. Oh, wait, let's change it back into, meters, okay? And the reason is because the height of the object, let's put HO, is 1.5 meters, and the distance of the object is also in meters here, okay? So what you're going to do is take 60 centimeters. Okay, let's write you dividing it. Divided by 100, which is 0.6 meters, okay? We're still going to keep the negative sign there, okay? So this is actually now my focal length, okay? Let's put it into the formula. So 1 over di equals 1 over f minus 1 over do. Okay, and so now we're going to use negative 0.6. So let's just put the negative at the top, okay? Don't ever put the negative sign in the denominator here. Okay, and I have the distance of the object is 6 meters. Okay, so just like this. If you want to do a common denominator here, just multiply them by each other. So I'll times it by 6 here. And then times 0.6, okay? So if you do 0.6 times 6, okay, your common denominator here is 7.6, okay? So remember, you're just multiplying it together. Sorry, so 3, okay, 0.6. Okay, so you times them together. And on the top, you're going to have negative 6 minus 0.6. Does everyone see that? Okay. So again, don't worry about all of these decimals, okay? Because it's not going to make a difference. And you'll see just in a second why. So I have negative 6.6 over 3.6. One more time, this is 1 over di. So we're going to just flip over our fraction on both sides here. And when you're looking for the value of di, okay, this is going to equal to 3.6 divided by negative 6.6. Okay, I'll just write it on the bottom here, okay? So now we're actually going to divide the two numbers. Okay, and we are getting 0.55 meters. Okay, and I'm just rounding it to 2 decimal places here. Okay. And what you're going to do now is you're going to take, okay, this value, okay, and I'm going to plug it back into my equation here, okay. And notice that the value is really small, and the reason for that is because this is the distance of the image. This is in meters, okay? So you can always convert it back into centimeters as well, okay? So let's put it into the formula here. So if you want to just convert this, that's all right as well. I could just times this by 100, okay? And your distance of the image would be 55 centimeters. All right, so just like this. So for now, we're just going to keep it in meters, okay? So everything is in the same units here, okay? So let's plug in. So what we're looking for now is going to be the height of the image. I'm going to write out the formula. Negative di over do equals hi over ho. Okay. So let's take our DI value here. Okay. So if you want, you could put everything into centimeters as well. Okay. So it doesn't really make a difference here. Okay. So let's put the DI. Let's use the centimeters here. Okay. So I have 55 centimeters. Okay. I have my DO value. When you times that by 100, it's going to be 600 centimeters equals HI. Okay, and I have my HO value here. Okay, times it by 100. So this is going to be 150. Okay, usually the units that are used often is the centimeters. Okay, so that's why I'm just going to convert it here to make it easier. Okay, a little bit of simple math here. Make sure you are just cross multiplying these numbers. So I'm doing negative 55 times 150. Okay, and then divide it by 600. Okay, so put that onto your calculator. Okay, and we are getting negative. Oh, sorry, your value here should actually be negative, okay, because we had negative 6.6. Okay, so I'm going to actually put the negative sign here. Okay, so this becomes positive. Okay, so positive 13.8 centimeters. Okay, so this is my final answer here. Okay, so you can just box it here. So again, make sure you are actually, so I'm going to put negative, right? The distance of the image again is negative. Okay, the image is forming on the opposite side of the mirror. And that's why you have a negative sign for the distance here. Okay, when you plug it back into this formula, remember this negative sign is actually part of the formula. Okay, so these two negative signs here, okay, they're actually, so I'll make it darker. These two negative signs are just going to cancel out, okay? So the value for 55 should actually be positive. Okay, I can see that the height of the image is also positive here. Okay, when the height of the image is positive, what that indicates is that the image is actually upright. Okay, so it is not inverted like in most of the other cases. Okay, and again, because this is a side view mirror here, the trucker sees the image of the car passing in her truck in her diverging rear view mirror. Okay, so this is a diverging mirror. So that's why the actual image is going to be upright. Okay, and if you really think about it, okay, the image is upright here. It's 13.8 centimeters in terms of the height. Okay, and I noticed that when I'm driving my car and you're looking in your rear view mirror, you don't see all the images upside down. Okay, they are actually right side up. All right. So I can see there are some real life applications, okay, using the mirror equations here because we use mirrors in our daily lives as well. All right. Okay, so that looks good. All right, and if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone in the next video. Thanks, bye.